All right, now we're recording. So this is where we are, and we're supposed to start getting numbers, and it's pretty easy to do this one by hand. But I want to start today doing computer work. Okay, that's the goal today. Y'all have computers now. I have a computer. We're going to do computers together. And so first off, let's all go to geogebra.org. Geogebra.org. This is where we're going to always go to do our math for this class. Okay, so every problem, any math problem that you have to do, it'll be here. We want to go to classic, and this is where I'm kind of confused. I don't see it up here, but it's GeoGebra Classic, and sometimes I have to look around, and maybe it's around. I don't see it. So what I have to do often is I need to click it. They have it here? No? Okay. So if you do /classic like that, geogebra.org/classic, then it pops up with this thing. So I don't know how to get there otherwise, but this is where we need to be. Okay. Let me see if I can reload and get that thing better looking. Yeah, there we go. Okay. Are y'all kind of understanding what I'm saying here? Like where to go and all that? I want to make sure that y'all are here with me. If you're not with me, you say, hey, Chad, and I'll stop everything. You get me? Because I'm here for you. You come first. Well, let's get started with something basic. So I'm going to go to spreadsheet. We're going to do the probability other days. This is like chapter 4 and onward, but here's what we're doing right now. So spreadsheet. You don't need any of this. That doesn't really matter. Let's put some numbers in. And we're gonna see an average. Let's do a basic average and stuff. So let's do some like 18, 19, 23, 24, 34, and 39. That's good enough. So let's just kind of zoom out for a second. What do you think the average would be? Just kind of guess for me. Is it going to be like 40? Is the average? No. What is it going to be? Just give me a guess. 20 something? 20 something? Yeah, exactly. It'd be 20 something. I don't know which 20s, but 20 something. So we know if we did something wrong, we look at it like, ooh, that ain't 20 something. You know what I mean? Let's go back and try something else. We should keep that in our brains always. So I'm going to click, drag, and highlight it. And this is just a demo. We're going to do the actual math from the workbook soon. And I want to find the average. I want to find the median. I want to find all these things, right? Give me all the answers. And so there's this little button up here, and it's going to be one variable analysis. Depending on your device, though, it might like pop up weird. You have to like click it twice or something weird. It depends. But you're looking for this one variable analysis thing, okay? And you click it, and it pops up with stuff on the side. Are y'all feeling me here? Oh, I'm okay. Do I come to you or am I waiting? Okay, cool. So this is a lot of meaningless stuff. I don't know why they keep popping this thing up. It's kind of meaningless. They say it's a histogram, but this doesn't help me. It's right here. This is what we actually want. This show statistics, little sigma X button. Okay, so once you click it, it gives you all the numbers. This is what you actually want. So the mean, the median, minimum, quarter stuff, we'll learn that today. These are standard deviations. We'll learn that today. All this stuff, all of your answers. It's right here. You're done. So look, the average is 26.1. So 20 something, right? Cool. So confirmed. Pause. Are y'all okay with what we're doing? Because I'm about to make it more and more. We're gonna keep building on this. Yeah. Okay. You tell me if you're not. I'm serious. I stop everything for you because you're here, first. All right. So back to the workbook. I'm going to start doing workbook problems like this one. It says, hey, we have a score, we have a frequency, and we want to find the average. So think about it like this for a second. This table is showing like a really condensed version. We have 30, but then there's 3 of them. So in a way, it's like saying 30, 30, and 30. Okay, and then I have 33, but how many I got is 4 of them, right? So 33, 33, 33, 33. So like if I were to start to write this out manually, I'd have 30, 30, 30, and I got 33, 33, 33, 33. 40s, I got 4 of them, 40, 40, 40, 40. and then I got 150. Now, and then I can go and find the average, right, by adding them all up, divide by however many we got, blah, blah, blah. But, like, this is silly, isn't it? And what if you're not having, like, 3 and 4, but what if you have, like, 20 of them, right? You don't want to do that anymore. So how do we make this work in GeoGebra? That's going to be my question. I want to get this all done in GeoGebra. What do I do? So I'm going to side-by-side it. And can I zoom out maybe? Okay, yeah, that's great. I want to put all this in here at once. So I delete all this, and what I do is I highlight, and then I hit delete or backspace a whole bunch. Just one time doesn't do it. I don't know why. You got to do it 2 or more. But once it's all cleared out, then you can start typing new things in, right? So I'm going to start with the X's. So 30, 33, 40, and 50. These are my X's. And then I want the frequencies, 3, 4, 4, and 1. Notice that I've changed my table. Yeah, my table was going sideways. Now it's going down. That's okay. We could put labels on that in GeoGebra. I just don't think I want to keep that in your brain. This is what you really need to do. So far, is that okay? Like, if you got 2 columns, you put 2 columns? This is a training demo. We're good with your training demo? Okay, good. I want to find the average. Highlight everything you got. And when you're highlighting 2 columns, GeoGebra just understands that you're doing something different. So if you click on the one variable analysis, you'll get kind of like special numbers now. But let's pause for a second. It looks like I should do 2, right? I got 2 columns. Shouldn't I click the 2 button? Well, that's not now. And this will be for later. That's actually chapter 12. Okay, we're going to do that in chapter 12. Cool? So forever, as far as you know, we're always going to one variable analysis. Okay, one variable analysis. And where's my stuff, right? And this is where we're learning our devices. So if I scroll my stuff over, oh, there it is. And then I can click my little Sigma X. And then I got numbers. Cool. So my average, what was it? What's my average? 36. What's my median? What's the middle? 33. You know what's kind of interesting here with 33? We can calculate that manually. Like, we have all this data listed out, right? So let me go through the list here. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 of them. So like 6 on each side. So let's do 1, 2, 3, 4, 5, 6 on this side. 1, 2, 3, 4, 5, 6 right here. What is the average between 33 and 33? 33. There you go. We just found the median right there. Boom. Yeah. And that's what it's doing for us. We don't have to do that anymore. Isn't that cool? GeoGebra's doing it all for you. This class is type it in, get the answers. Isn't that cool? Yeah. Yes, I can. I can come. Okay, because it's going to get some complex stuff. Hello. If you want a computer, you can get a computer anytime you like. We're doing computer work today, but your call. And thank you. All right. So let me write this stuff down. It says find the mean and median mode and all that kind of stuff. Well, I mean, on the workbook, I better do it, right? So I'm going to write mean is 36. The median is 33. And what's the mode? What's the most frequent value? So isn't this 4 of these and 4 of those, right? So it's actually bimodal. We saw that a couple times earlier where there's 2 of them. And so it's like 33 and both 40. They're both the same hosts. Password and username password is student. All lowercase, student and student. Huh? Oh, bimodal? So I was saying, like, what's the most frequent values? Well, there's 4 of these and there's 4 of those. So I said bimodal because there's 2 of them. Bi means 2, like a bicycle, you know? Like, because there's 2 wheels. Just saying. A tricycle is 3. Sure. Let's do that, bro. You know what? Let's get a PhD together. You know what I mean? I'll write it. You put your name on it because you had the idea. Boom. Oh, that's awesome. Okay, good. Good with the computer side of things. Let's keep doing this. I want to do this more and more with the computer. So we'll come back to that. Let's keep cruising. You know what's funny is that this is the exact same question from above. Yeah. Good job. Good job. Very good. Cool. Anybody else? I had the headphones off. It's okay. That'd have been weird, right? Anyways, so it's the same question from earlier, right? It says find the median. Well, we already found it, so I'm gonna just say like look up there. I don't know, but that's why GeoGebra does it all for you. Is that cool? I'm gonna keep cruising. Look at all these numbers. It says find the mean, median, mode for all these guys. All right, go ahead and start doing it by hand. See you in about 15 minutes. Right? Wouldn't that take forever? What would you rather use? GeoGebra. So again, how would you do this by hand? I'm just going to show you briefly. You could say there's 19, 19, 20, 20, 20, 20, and like that takes forever. Another way to do it though is if you multiply by each frequency and yet add them still up like this. So I would say 19 times to 2, 20 times to 4, 21 times to 2, and I keep adding. And I divide by the total frequency, which would be the 2, the 4, the 2, the 5. It would take forever, though. We don't want to do that. And if you do all this right here, couldn't you make a mistake somewhere along the way? And then you're like, I got the wrong answer, but I don't know what happened. This is a perfect example of like why we don't do that anymore. So GeoGebra, here we go. Everything in GeoGebra. Can I fit it all on the screen? Awesome. So I'm just going to start typing it. Remember that we have like the first column here is your first row in this case. So 19, 20, 21, 22, 23. And in this case is the frequencies 2, 4, 2, 5, 6, etc. So I'm just going to keep going. 25, 26, 27, 28, 29, 30. It's kind of convenient. 7, 8, 8, 2, 3, 5, 2. Man, you are teaching me how to do things. Let me try that. This one? Oh, left. I see the blank little corner thingy. That's what I'm going to call it. The blank little corner thingy. Long name. Yes, I like that. That's pretty cool. Let's see if it works. I think so, but we're going to check. So, one variable analysis. Always, always, always one variable analysis. And then this little sigma x on the side. Little sigma x. And there's all my math. Cool. So 14.5 is the average. Is that right? Oh. Well, so, and that's interesting we're getting different results. So think about it. This is a perfect time to analyze what's going on. I just click something and it looks like it's cool, and I hit this and I get an average of 14. Is this an average of 14 miles per gallon? No, no, and no. So something's wrong. Let me try just selecting them by hand, right? So I'm going to say, like, let me just do this and see what happens. And so, like, you do it with me. You might get different results too. One variable analysis. Try it again. 24 now. Yeah. And so you had a lot of blanks. What might be happening is it's reading these blanks as like zeros or something. Who knows? It might have just been something weird. Does 24 miles per gallon make a little bit more sense? Yes. So, okay, don't click the corner blank little thingy, right? Apparently it looks like it works, but then it doesn't actually. And so there we go. I'm going to start writing some numbers down. I mean, we got them, right? It says find the mean, median, mode. So the mean, 24.57. Yeah, okay, good. Yes, yep. When we're working on the homework, they'll have things that you can copy as well. Oh, that's pretty clever. So yeah, there's lots of little things that we're going to be learning. Median, 25, and then the mode. Now, what's the mode from GeoGebra? Does it tell us? Does it have mode up there anywhere? No. So we have to do it by hand, and that's okay. Remember, most frequent. We're looking for the most frequent numbers. What would they be? Yep, yeah, exactly, 25 and 26. Well, there's two of them now, right? Oops, wrong one. Erase. I'm gonna erase this. Sorry. Where's my eraser? Erase. Okay, there we go. Yeah, 25, 26. So would I just say 25, comma 26? I guess. I don't know. That's the best I got. Bimodal. Someone got a PhD for it. Yay. I'm only half joking about the PhD thing. People have gotten PhDs for a lot less, let me tell you. Okay. So, but it's okay. It's okay. Questions? Answers? Okay. Awesome. Scrolling on. So, frequency distribution for the mean, the average city mileage of 24 sedans. This is a perfect example. We're wanting to use the computer. We're wanting to use GeoGebra. Okay. Let me try it. Right here. I would say, please don't do this at home because it's going to get dangerous here. Did you see that? Look what I'm doing. Right? What the hay is going on here, bro? All right? GeoGebra doesn't understand. It doesn't understand. It thinks I'm wanting to subtract them, right? It's thinking subtract. That's not what I want. That's not what I want, GeoGebra. So in order to make this thing work, and this is why the workbook has this, I need to use a midpoint. And I'll use the midpoint as my first column, okay? In a way, GeoGebra wants these two columns here to do the work. So I need to find the midpoint for each of these. And we've done this before. I mean, it's kind of not too hard. 22, 23, 24, 25, 26, 27. So there's 6 numbers in there. So like 3 and 3, right? So if I count 3 over and cut it in half, so 22, 23, 24, 24.5, exactly. 24.5. So 28, 29, 30, 30.5. And let's just verify that we're doing this right. Like from here to here, what am I adding each time? What's my class width? From here to here. How much is that? 22 to 26. How much is it? 6, exactly. How much am I adding from here to here? How much am I adding? 6. How much am I adding from here to here? 6. Yep, there you go. And we can keep going down that road very quickly to figure out the rest of them, right? Just like that. Make sense? Okay, cool. Now let's type those in. Midpoints first, and then the frequencies. 16. Wow. 2, 2, 3, and 1. Ooh, that's a lot in the 20-something range. So I'm going to click, drag, highlight, select all the stuff that I want. One variable analysis. Sigma X. There we go. Start writing some stuff down. So 29.25. My median, in case they're asking, is 24.5. Now this is an interesting one. We'll talk more about the median here in a second, okay? And then the mode, what would be the mode in this case? Yep, 24.5, exactly. I'm gonna put question marks again for just a second. Okay. Are y'all cool getting some numbers? Yeah, okay. Are y'all okay with the mean? Does that make sense, right? 29 point something? Is that probably an average for these guys up here? That makes sense? Okay, because there's a whole bunch in that 20-something category. Okay, so why did I put question marks for the median and the mode? See, the median is actually whole number values, I guess you could say, and then we're literally just cutting in half, right? Do I actually have how many whole regular number values I have here? No, it's like compressed data already, right? They're just saying, in this range, we had this much. But I have no clue if that was 22, 22, 22, 22, 22, 22, 22, 22. You get what I mean? Or was it 22, 23, 24, 25, 25, 25, 25? I don't know. No way to know. So does the median make sense in this case? Not as much, I would say, right? I mean, it's just saying now, what's the most frequent class? Does that make sense? So what's the most frequent class would be this guy, that class. So kind of, but kind of not. The mode, again, is the most. Oh, I'm sorry, median is the middle. Mode is the most. Okay, regardless, blah, blah, blah. This is okay, but I would still not use it very much. This is what they're asking for anyways, and we're done. So, but we talked about it. Yay! I know, right? Woo. Good? Are y'all happy to not have to do this by hand? Okay, good. That's a good thing. You're not bored or nothing? So let's keep going. We're going to use the computer more on this section, but I do want to like fill in some stuff here, okay? So range, we remember it's max minus min. But I don't really know why that's important. We're talking more about right now population variance and eventually population standard deviation, which is, where did it go? Oh, they just have them sample standard deviation right there. I want to give you like a summary topic of what standard deviation is. If you don't mind for just a whole second, let's just talk about it and then we'll come back to this. So this is more like a sit down and ooh and ah thing, I know. I'm going to draw a bell curve, okay? And in the middle of the bell curve right here is the mean. That's my average. Now, I did not draw a very good bell curve, just saying. But do you see where there's a point where, let me use a different color for a second. You see where there's a point where it goes from like a cup down to like a cup upward kind of shape? You see that shape in it? Where it's changing its shape from like cup up to cup down, that kind of thing, is about right here and about right there. And those are called inflection points. Inflection points, okay? In math, in like super mathy terms, it's when the second derivative equals 0. What the did you just say? Stop cussing in my class. Moving on. It's where the shape changes. Cool? Okay. Now, the important thing about these inflection points is that the distance from here to here, and I know my bell curve is not perfect, but this distance here is a standard deviation. That distance is equal to a standard deviation. Deviation. I don't think they have it right here. Oh, right here. This is it right there. You can see like deviation squared and all that kind of stuff. So that distance, same distance here, because it's symmetric, isn't it? So that same distance here. This is a standard. I'm going to put STD DEV. Is that okay? Standard deviation. It's that distance on the bell curve. What we want to find are these distances because they're meaningful when you're looking at the greater picture. Okay. Another color. Here we go for a second. Let's do a darker green. Because, and again, my bell curve's not perfect here, okay? The percentage amount inside of this zone here, inside of this zone, is 34% of the population. And the same thing with this, inside of this zone is another 34%. Therefore, from both of them together, you get 68%. Okay, so I'm going to just real quick do this here. 68% of all data, all population, all stuff. So let's just pause on the significance of this for a second, okay? Let's say we're trying to find the average amount of time that it takes to drive here, okay? So I take a long time because I live over in Temple. Some of y'all take like 5 minutes maybe. Who does 5 minutes or so? 5, 10 minutes? No, for real? Okay, 5, 10 minutes? Okay, cool. Who does 30 minutes? Around 30 minutes maybe? Okay, cool. Who does around an hour? Just me? Okay. So it depends on traffic. So I'm going to skew everything with the average, right? So the average is going to look like a lot more because mine looks really big. Some of y'all are kind of small, that kind of stuff. Well, we find an average, right? And that's fine. But I want to know how many of y'all, or maybe how many of the people at CDC are within a particular range. So I'm going to make up a number, okay? Let's just say the average was 20. Y'all are like, y'all are hanging with me, right? Let's just say the average drive time is 20 minutes, okay? And then I do a lot of math in GeoGebra. Okay, you get me? In GeoGebra, we do a lot of math, and we find that this distance here is 10 distance from here to here. Let's just say, okay? So 10 minutes. And so therefore, right here, I'm going to say 10, and on this side, it's going to be 30, right? Because I'm going from 10 distance on each side. So I started at 20, and I got 10, and I got 30. 68% of people here at CDC, this is the claim here basically, is that their drive time is between 10 and 30 minutes. 68% of people fall in that zone, okay? After I did some math. That sounds pretty logical, right? Some people could even be smaller than 10 minutes, and some people could be even more than 30 minutes. Yes? But 68% is right here. Good so far? I'm going to go to the next level. Here we go. So that was only level 1. I need more room. Here, this is perfect, right here. I'm going to redraw it so that I can get more room. My bell curves never come out really good. I'm sorry. I'm trying really hard here, bell curve. Bell curve, bell curve, bell curve. Come on, bell curve. Oh, it's going to be close. And so there's my average. There's 20. And then my inflection points right here and here. And so now we're at 10. And we're at 30. And this right here I'm saying is 68% of people. Okay, so here we go. New color. Let's do a purple. Okay, I'm going to go another distance, another standard deviation. So again, this distance here, we already said was 10. So I'm going to go another 10 on both sides, okay? So if this distance was 10, I'm going to go another 10. So if I went 10 more onto the left side, what do we have right here? 0. What do we have on this side? 40, okay? Here's the new statistic. Here's the new number, 68 for these guys. But this zone here is now 95% of all data falls within 2 standard deviations. Okay? So I'm saying that 95% of people on campus are driving 0 minutes up to 40 minutes to get here. Okay? I know this is going to be weird, but do we have some people that live in the dorms? There you go. So how long did you take to drive here? You walked, exactly. Oh, my bad, then. My bad, bro. But the bigger point is to get to campus, you didn't really have anything at all, so like 0. Or if this was a more continuous set of data, you can even go negative depending. That doesn't make sense in here, but I'm just saying 0 would be the cutoff line there. But 40, I drive more than 40, right? I would go over here and I can keep going to the next level, but maybe I'll find out that I'm like at 45 or something like that. Okay, I'm outside of this 95% zone. Make sense for a second? This zone here, this 95%, is called the usual zone. All of this stuff in here is usual. People, like 95% of people are usual, are normal. You thought, man, I'm not very normal. I'm kind of weird. You're not. Well, at least probably you're not. I thought I was weird, but I'm still pretty weird. But 95% of people are just normal people. Okay? So what would be the people that are not normal? What are the people that are unusual? What percentage? If you 5%. 5% of people, so I'm going to say 95% are usual, but then 5% are unusual. And they're going to be in these two zones over here. Again, I kind of picked some bad numbers because negatives don't make a lot of sense on here. But you would have on this side 2.5% and another 2.5% on either side. Because it's symmetric, right? So if you have 95 in the middle, you got 5 left over, you split it in half. 2.5, 2.5. Cool? We can keep going on this, but you're seeing the idea that, I mean, we can go 3, we can go up to 5, I think, is where it kind of like cuts out finally. But 2 is a really good one. You're seeing the importance now. I can tell you that 95% of people are from 0 to 40 minutes drive time after I do the math. Good? Make sense? So this is why we're doing it. Now I'm going to say, what are we doing, right? How are we doing it? And that's GeoGebra, okay? So let's fill out the rest of this stuff. I'm just going to like talk about it briefly, but we're going to really just use GeoGebra here in a second. So what we were looking for, what we were finding was the standard deviation, okay? And we label it with this little circle with a line on it, and that's called a sigma. That's this guy right here. It's a sigma, okay? It goes s for sigma. It's a lowercase s, in Greek. Okay, so it's a Greek letter for s. Why is that up there? Go away. Okay, good. Anyways, so that's great. Awesome. So, Chad, why do we have this big population variance thing? And why is this little thing squared here? So the variance is sigma squared. You're literally taking that number and you're squaring it. So like we had a standard deviation of 10 back up here. That distance between them is 10. So here it's going to be 10 squared. What is that? What's 10 squared? 100. Now, which of these numbers for you and me is more important? Is 100 drive time minutes making any sense with the graph that we have up here? Not at all. Is the 10 minutes making sense up here though? So when we go through all this stuff, this is important to you. This is what you're going to have to use again and again and again in the brain, on the math, all that stuff. This here, you'll have a couple questions and you'll move on, okay? It will occasionally ask for it, but I'll show you how to get it. I don't even think GeoGebra provides this. That's how, like, nobody cares about it, okay? Now, I'm going to just tell you, just a side note, because it's on the recording, I actually had a full statistics class in graduate school devoted just to the variance. But that's graduate school. We don't need to do that here. So, moving on. So, they're trying to tell us how to do all this. It says find the mean, calculate this, subtract that, find them up, add them up, blah, 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 GeoGebra. I'm serious. Are you ever going to be tested on how you do it by hand? Probably not. Actually not. I'm just going to say no. No, it's always going to be with GeoGebra. And so it says find the range, mean, median, variance, standard deviation of this stuff right here. Where are we going to go to do that? GeoGebra. Let's go and find it. So we got these values here. What could those be? 22, 10, 6, 9, 8. What could those values be? Just give me some real world for that. Minutes of drive time. Let's do that. Minutes of drive time. So 22, 10, 6, 9, 8. Awesome. I'm going to do the same thing as I always do. Highlight, one variable analysis, sigma x, and then we got our numbers. Again, I want to make sure I'm doing this right. With an average of about 5.5 makes sense for this. No, I'm sorry, 11. I was looking at the wrong number. 11. Would the average of 11 make sense for this? Okay, good. So let's start writing this down. You don't need this. I don't know why there's big things here. We're not doing that. We're just going to write down the answers. The mean was 11. The median, in case they ask, was a 9. I don't think they really care, though. It says find the range. There it is. Yep, that's the max minus the min. My maximum was a 22. The minimum was a 6. You can see it there just in case. So how much was it? 14? 16. 16. Yes, 16. There you go. Awesome. Now I want to find the standard deviation. Remember, it's that little sigma thing, right? Little circle, the line up there. See it? 5.65. There we go. Round to whatever they ask for, of course. They might say 3 decimals, you got it. 4 decimals, you got it. 2 decimals, you got it. It's not a big deal. Okay? Cool. All right, we did it now. We did it. That was it, right? Uh-oh. No. What am I missing? This says the variance. Oh, okay. So remember what we're looking for, variance, right? We're supposed to find this little sigma squared thingy. It has to have a little square on it. Okay? We're looking for the sigma square thingy. Do we see? Oh, I see this thing with an X and a square. That ain't the same symbol. Look, they can do their little circle symbol. Circle symbol with a square. Do you see anything like that? That's why we don't care. It's just so meaningless to us. I'm sorry. It's not meaningless. It's not meaningless. It's so meaningless that GeoGebra just does not care to tell you. But we can find it. We have to find it. It's going to be on the homework. Occasionally we'll have to find it. So this is what we're going to do. I'm going to do this with a hand calculator, essentially. And I mean hand calculator, I mean this thing, like that, okay? And that's fine. Variance. I'm going to use GeoGebra, just hold on. So 5.65, and I'm going to square it. But I have to do it manually. So I went to Desmos one time, and I totally recommend Desmos over this. Because I don't think GeoGebra is as nice, personally, for this. But we're just wanting to do like regular old calculator. Math calculator, is that something? Start the calculator. That's not what I want. Can I just type something in here? Do you think it's going to work? Okay, 5.65. And I'm going to square it. Okay, great. Thanks, GeoGebra. I really don't like this. I truly prefer, I'm not going to use GeoGebra. I don't really care. I'm going to use Desmos. Or we can use whatever the heck you want. I don't care. But so I got the 5.65 squared. It gives you a number, and you're done. Okay. So phone calculator, right? You could always do that. Is that cool? You can use like a literal hand calculator. Anything. I don't really care what you're using. You can go to Desmos. You can even do GeoGebra if you really want to. But we've got to do this by hand. Okay. So what is the 31.9 drive time, right? That's what we're doing, drive time. Does that mean anything to you up here? No. Did the 16 mean something? Yeah, I guess, subtract those two, I guess. Or, well, those two. The 5.65. Could you see a bell curve and say it's about, what was the average again? What was the average? Was it 11? No. Yeah, 11. Could you see 11 and then plus or minus about 5 on each side? So 11 minus 5 would be 6. 11 plus 5 would be 16. So I'm saying that 68% of data is between, I'm just doing a little bell curve right quick. We had 11 here. I'm just going plus and minus a little bit. Minus the 5 would be 6. Thank you. And then we had the 16. 68% of data is between 6 and 16. Look, there's a 6, and that's a little bit outside of it. So far, it's not too bad. If I kept going, right, and I subtracted another one, I'd have -1, so like down to 0. And then I'd have 22? Would 95% of data, would most data fit in between 0 and 22? Yeah. Cool. And just between you and me, guys, right? Can you find an outlier up here? Which one's the outlier? The 22. Look, everything else is 10, 6, 9, 8. These guys are all really tight. What if I got rid of the 22 entirely? It would change all my numbers. But you can see that even if I didn't get rid of the 22, it's still within the 95 zone. Cool. Okay. Any questions on this? Wow, Chad. They just said find these 4 numbers, and you blah blahed for like 20 minutes. Because it's exciting. Moving on. So there is a difference between population and sample standard deviation. If you go back up, it said population versus sample, right? And there's only one tiny change, is that they use n-1 in the bottom versus an n. You see that? There's only a tiny little change right there. If I went back to GeoGebra, does it provide a little s? S for sample standard deviation? Little s? Does it have a little s? So I don't even have to do that one. What's the difference? It's either a population or it's a sample. That's all it is. It doesn't really. And look, are they pretty similar? I mean, in the whole grand scheme of things, they're not pretty similar, right? And the bigger you get a sample, the closer it is to the population. Therefore, the closer you'll have the same number. So they say do all this stuff over again, blah, 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 for these 2 books. Let's do it. In GeoGebra. You ready? I'm going to start doing it. You're going to start doing it. Oh, no! Okay, here we go. In a lot of my other classes, like the algebra classes, I've been doing this new thing called I do, you do, we do, where I do a problem on the board, and then like everyone does the problem while I'm trying to be quiet, and then like afterwards we do the same problem together on the board, and they help me out and stuff, right? How about y'all do that one? I'm serious. Y'all get the numbers, and then you're gonna tell me if if we get the same thing or not. So don't look at my screen, bro. Just want to see if y'all can get it. Don't look at my screen. No. I think they want the sample standard deviation here. It'll always tell you in the homework. You're testing yourself. Can I get this? Chad says I can. Chad can run and come and help you. There's no shame in this. Unless one of y'all want to come up here and give it. No. Okay. I guess. I mean, I'm only going to post it on my YouTube channel. Come on. You could be famous. Actually, I've been thinking of doing a Harvest Moon clone. Yeah, I have. I've been trying to do that for the past 12 years, and I make one and I fall apart and try one. Yeah, I made mobile games for a while. That didn't really fly that well. No, no way, bro. You have to keep them things updated. I've tried all kind of things, but yeah, that I really want to do a Harvest Moon clone like a good one. So if y'all don't know what that game is, it's like that's old school, like cozy games. There's no combat. I know, no combat? What are you talking about, bro? Y'all have plenty of time. Did you get the same numbers that I did? Yes? Okay, good. So, and I can pause, we can redo it, whatever you want, but I just want to kind of see, for your sake, are you getting what I'm getting, you know? Cool? If you're not, I can come to you right now. Richard, I didn't get this. I'd come running over and help you, because that's what I do. Okay, so there's actually words with this problem. See, it says the length of the first 10 or the 10 words of the book, blah, 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 that kind of thing. So find all this stuff, which we kind of basically did. And then it says, does there appear to be a difference in variation? Variation, variance, standard deviation. They're talking about the standard deviation, essentially. They're saying, is there a difference in these two numbers here? Yes. Yes. So what does it mean then? You see, like I have an average that's 3.9. So 3.9 letters per word. Yeah, kind of small. But what does this mean here to have only 0.99 standard deviation? Can I draw a little bell curve for you? So I got 3.9. And let's just call that 1, just for ease of use, right? So 2.9, 1.9. Over here I got 4.9, 5.9. So I could say that 95% of all words, at least using these 10, would fall between about 2 and 6 letters. Is that what they're saying? Letters? Yeah, the length, so it would be letters. Cool? So 95% of the words in this book are from 2 to 6 letters. Does that make sense? What kind of book is this? It ain't a math book. Right? It's like a kid's book, yeah? Like a children's book almost. Okay. Can I superimpose on the same thing? Here, give me a second. Let me show you something really cool with this. I want to draw this, but on the same number line, using the red now, okay? So same number line. The average is 7.4. So let's say that's 2, 4, and 6. So far, so good. So this is a 5, this is a 3, and so then let's call that a 7, and then this is an 8, and so 7.5 would be the average for my new bell curve. So good, so far, so good. Now, it says that the standard deviation is 3, let's just call it 3 to make it easy, okay? So 3, I'm going to start right here and go 3. So right here, 1, 2, 3. This is the standard deviation. This is actually the very first inflection point. Okay, let's go this way, the other way. So that'd be 1, 2, 3. So about right here, this is the first inflection point. The first inflection point, guys. And I don't think it's statistically sound to be putting them on top of one another like this. But that's supposed to be the average. This is the first inflection point. Do you see the bigger difference here? Now, I'm not trying to make it bigger. The bigger part is just because I need to draw it on top of one another. I'm saying that there's a lot more variation. You got like words like A and I, right? The little ones. It, to, go, that kind of thing. But then you also have things way over here like, give me a big word. 20. Okay, I'm going to do a big word here. We got a big word here. Come on, math. Give me a big word here. Population. That's a big word right there. Oh, yeah. Right? Big word. Lowercase. My bigger point is that, like, you got the big words and the smaller words, and the, got Latin in there probably and all this other stuff. What kind of a book would this be here? A what? A picture book? Okay. I was thinking a science book. Something with science, with like lots of big words, like this worm has a new disease and we're going to call it. So I don't know. Okay, cool. So that's the analysis behind it. Now, what are you going to click on the homework? You click A, B, or C. Moving on. So, see, I'm having fun up here with you guys. Yay. Okay. Sample standard deviation using frequencies and stuff. If we can find the average of this stuff, can I find the standard deviation with it? Yes. So back to what? What are we going to do to find the math here? GeoGebra. Let's do some GeoGebra action. Same as last time, same as every time. 0, 1, 2, 3, 4, 5, 6. I have seen on the homework where Newton is mean to us. I'll tell you straight up what they're going to do on the homework, just once in a while. 0, 1, 2, 3, 4, 5, 7. Oh yeah, and that's going to change all your numbers. They're going to be off by like 0.2, and everyone's going to get angry. The homework does this sometimes to you. Be watching out, okay? Watch out. They'll do that. They'll be mean to you for no reason. Okay. Take all this, one variable analysis, sigma x. We're getting to become professionals at this now. Are you a GeoGebra master yet? Yes, Chad. Okay, good. Good thing I'm filling in for y'all. 1.7225. Notice that it said the sample standard deviation, so that's why I was using the little s. And this guy, of course, is just the mean. Well, you don't really have anything for that. Okay. So one thing that I'm learning, and I'm just going to write this as a side note here, anything from the population uses Greek letters, okay? Anything from a sample uses Latin characters, Latin with an L-A. So if Latin characters means English, right? That's what we use in English is Latin characters. So if you see like a little s or something like that, and again, N, those kind of things, that's sample stuff. Population would be Greek letters. And so you see the sigma, and sometimes they have like mu, which we haven't really seen yet much. Just as a side note, okay? Cool. Are you getting what I'm getting? Yes or no? Yes? Good. Okay. Is there anything else that we have to do here? That was it? Just find those two numbers. All right, we're good. That was it. I don't know what else to do here. Yay! I mean, we could draw a bell curve again, but it doesn't really matter. Wait. Yep, no more. We're good. Why is my mean here in 1.8? Where's that located here on this line, right? Up high? Isn't it like right about right here on this line? Does that make sense about the average right there? You can see that it's kind of halfway, isn't it? Where you got what, almost 30, I guess, right here, and then on this side you have almost 30 of those guys ish, something like that. So does that make sense? Yeah. Okay. Blah blah blah. Yes, Chad. When are we leaving, Chad? I know it's computer day though. I'm trying to get the computer stuff out the way. Okay, interpreting standard deviation is a pretty cool thing here, but I'm not going to go too much into it. See that the variance, that's the variation, the distance, if you have zero distance, then they're all the same number. That's what they're trying to say. Here we have a little bit of distance, so it's just that distance here is 1.2, and then again another 1.2. And you can see that bell curve there, right? That bell curve action. This one's just weird. And so sometimes you get weird stuff, and it says like you got 3. So like I know that's the average, but then it says to get to the first standard deviation is like way over there. Sometimes you just got to look at your data and say, that doesn't look right. Something's wrong here, or that's not making sense. That's not a bell curve. Okay, keep going. Pause. If there's anything you need to learn today besides GeoGebra, is this thing. Look, 34s. I didn't put the 13.5s for you, but I did put the 95 there, right? This right here. I'm going to write a little note here for you. Uh-oh, you're going to hate this note. I'm so sorry about this. Darn it, Chad! But I didn't have enough. Do you really have to memorize it? Probably not. But if you're needing to actually do this enough on the homework, it'll benefit you to have memorized it. I already told you some of the numbers, 68, 95, all this kind of stuff, but all of these numbers here we'll be using all throughout the rest of the class. And so if you memorize it, it just makes things go faster. Okay, faster. Would you have this available to you on an exam? Well, don't you have a note card? Right? Can you fit all that on your note card? That's up to you. I'm okay with that. I don't care. Okay, so what I want to do is I want to do one more problem with this, and I'm just going to draw all on top of this, and I think that we're going to be done, because at this point we're not using GeoGebra anymore. If you keep going, all this is by hand. So this is actually a nice stopping place, but I want to do this one since we talked about it, and then we're done. Is that okay? Hi. So, in a survey conducted for this and that, a sample of the mean height was this much. So the mean, the average right here in the center is 64.2 with a sample standard deviation of the 2.9. So they're saying that the distance to get over here, I'm going to add 2.9, and on this side I'm going to subtract 2.9. Okay, and so on and so forth. Go away, go away. I don't want to X because that's not what I want to do. Okay, there we go. Find the percentage that is between 64.2 and 67.1. We have to figure it out though. I already got the 64 and I say I'm minusing and plusing by the 2.9. How can I find what this value right here is going to be? How do I know what this number is going to be here? Yeah, you subtract them, right? Okay, so go ahead and do that for me. Oh yeah, calculator. So I'm going to get Desmos up to help me with this. So I got the 64.2 subtract 2.9. So I got 61.3. Do it again. 61.3 minus the 2.9. And again, I'm using Desmos mainly for the visual effect. You can use any calculator to get these numbers. 58.4 minus 2.9, 55.5. I'm going to go the other way. Starting at 64.2, I'm going to add the 2.9. Add the 2.9. Oh, 70 straight up. And then add the 2.9. Oh, I should have been able to do that. I feel really silly. I know, right? The math teacher can't figure it out. Yeah, I know. That's me. Okay. On your homework, this is what you will be doing. This is a direct copy of a homework question. I know I've seen it many times. This is what you would do. Now, do you have to draw on your workbook? Probably not. Can you draw it on the side, though? Ryan, on a little piece of paper? Okay. So we're looking for the amount between 64.2 and 67.1. Let me get a new color. 64.2. Oh, that's right here. 67.1. Oh, that's right here. They're saying between these two guys. They want to know what's the percentage here in between these two. What is it? 34. Wow. That's your answer. Like literally that's your answer. 34. Enter, submit, great job, all that stuff. So you mean I spent all that time just for 34? Let's do another one. It says less than 70. So 70 is over here, isn't it? Oh, let's do a different color. Let's do a dark green. So 70 is way over here, isn't it? And they're saying less than 70. They want all of this bell curve. And I mean, it keeps going. It keeps going as you keep going out there. I want to know all of this added up. That sounds like a lot, doesn't it? Now I'm going to ask, is it 100%? Is this 100% in the bell curve? No, but it's close, isn't it? Now, you might want to think, well, it's 100%, but minus the 2.35. Well, there's still more over here as well. Now, it's not much, but it does keep going. We're getting close to that, yes. That's that same idea. 95, very close, minus something. Okay, so this is what I do. You could definitely do that method, but this is what I'm going to do. I'm a little bit more crude. I'm going to just add up what I see, kind of. I'm going to do this. How about this? I got a better idea. Scroll up for a little bit. Scroll. Okay, there we go. From here, this is the percentage they don't give you. Right down the middle. Yeah. How much, we're going to keep going forever and ever this way. How much percentage is on this side of the middle point? 50%. So do I have to add up 2 and 13 and 34 and all these other numbers? No. I can just say all of this right here, all this over here is 50. You get me? Makes it easy. And then I have this zone, and then I get this zone. This is a 34, and this is a 13.5. So that's what I'm going to do. Can you subtract? Could you use the 95 and all that? Yes, yes, and yes. But this is Chad's method. Yep, that sounds about right. There you go. 97.5%. And that's what they're going to want. So 97.5% of all people, or all women, I guess in this case, are less than 70 inches. So there we go. Lots of different methods, but that's what I would recommend, because they don't actually keep, it keeps going, but they don't give you the numbers over here, right? You have to just kind of know what to do. So that's why I just go halfway, make sure I got everything over there, not a big deal, and then I can just add up whatever else I need, okay? Other times we'll subtract, etc., etc. Is that okay? Any questions on this? Okay. Well, then we're done. We're done. Yay! Thank you, guys.